So just a bit of background stuff. I spent considerable time, nearly 25 years as an airworthiness officer, working for DCA, DOT, ATG, CA, and eventually for CASA. So the following tales are pre-DCA and between CA and CASA. I took a redundancy at CA in '92 and went to the other side of the fence. So over the years working in aviation industry, I've experienced a few situations where lamies will not trust the indicators or the gauges and want to blame something else as being the problem, such as the gauge rather than what's really the problem. So I guess it's easier and cheaper to change a gauge than an engine. Most of my time in general aviation, I tend to specialise in electrical instrument categories, but because of my other licences, I happily dabbled in engine and airframe categories as well. So these are just a series of maintenance events. So about 1970, working for Murchison Air Services based at Perth Airport, we operated a mixed variety of aircraft, and one of them was a Cessna 210 based in Cal. On a maintenance visit to Perth, the pilot reported incorrect fuel flow readings. The engine was apparently running well, so the chief engineer, the boss, directed that I replace the fuel flow indicator. So we obtained a replacement indicator from the instrument shop at Jandakot, and I installed it. We sent the aircraft back to Cal. So a few weeks later, the pilot was back in Perth and reporting that it was still incorrect fuel flow indicator. Another replacement indicator was ordered from Jandakot, and again directed to replace it. So, but the serviceable tag on that instrument indicator was our original indicator, and that had been tested and no faults found. It was within calibration. So I refused to carry out the task, arguing the problem was not the indicator but something else. And I suggested it was the fuel manifold valve that sits on top of the engine. So that little beast. So it's connected with a couple of hoses and the injector lines. My boss wouldn't accept that, and me being revolting, I wouldn't replace the indicator. I argued that there was a problem with the spring in the valve. So finally we reached a compromise. I would remove the distributor valve and take it over the road to the Hawker to Haviland engine shop to be checked. If my troubleshooting was wrong, I had to pay for the check on the valve. That was out of the pay packet if I was wrong. But anyway, it turned out there was an incorrect spring fitted, and so instead of changing the valve, we had that spring replaced, and back we were with the correct actual fuel flow. So no well done from the boss. The gauge reading is fuel pressure, but it translated into fuel flow in gallons per hour on the indicator, and the value of the spring does modify what is actually read. And the reason I was so confident with my troubleshooting was that in previous employment with Air Pacific in Fiji, I'd done some pretty stupid troubleshooting of fuel flow indicator system on a Beech Baron aircraft. So it's a similar system, just that the Baron has two engines, not one. And in that case, the pilot reported that at the top of the descent, when the throttle was retarded, the fuel flow on the port engine just dropped off the clock, but the engine didn't miss a beat. So after a lot of needlessly changing of fuel system components, I finally replaced the distributor valve, and that fixed the problem. And I figure you'd have to be a bit thick not to learn from previous mistakes. In the early 70s, I spent a couple of years working at Woomera for Short Brothers and Harland, and they had a contract to maintain and operate the range ferry aircraft, and they'd taken over from the RAAF. So there was 3 Sud Aviation Alouette 3 helicopters, 2 de Havilland DCs, DHC-3 single otters, and the old Douglas DC-3. The aircraft there is shown with its military registration on the back end, but it was UPM when operated by shorts. Now one day there was some discussion about the turbine temperature indicating system on one of the Alouettes, and I was directed to remove the gauge and have it tested. Unfortunately, we had our own instrument shop that we'd inherited from the RAAF. The gauge was tested and found to be accurate. So the foreman then directed me to replace the temperature probe system on the engine because he didn't trust the indicating system. And we had an argument about that and reached a compromise. I'd draw the spare system from the store. Actually, we had a fantastic amount of spares that the Air Force had ordered to support those 3 Alouettes. It was unreal. But I wouldn't remove the harness fully from the engine. So I installed the new probes into the various locations and left the original probes hanging because I didn't want to unclip the whole harness. So we then had a pilot ground in the helicopter, and that proved my point that it wasn't a faulty system. The problem with this helicopter was a very dirty compressor system causing the engine to be way down on power. The engine in that helicopter installation is a very derated engine, so it had to lose a lot of power before it actually showed up on the cockpit indicators. The Alouette is powered by basically an 870 shaft horsepower, 2.3B turbo shaft engine, derated down to 550 shaft horsepower. So you can see it lost a lot of power before it showed up. We eventually removed the engine from the airframe and sent it away for repair. And the manufacturer was not very impressed with the state of the compressor, which is that area of the engine, because it was caked in a mixture of bull dust and engine oil. The 3 helicopters up there were equipped with big air filters on the engine intakes, and we locally know as big ears. And this is the only photograph I could find of an Alouette 3 with the big ears filtered, so that's the filter assembly up there. They were fitted to stop the erosion because the Air Force found that they were just wearing out the compressor assemblies with the good old red sand and dust. But the filter on this particular aircraft was becoming quite worn, and it was allowing the very fine dust, the bull dust, into the engine. And in addition to that, the front shaft of the engine had a fine oil leak, and either condition on their own probably would have gone some time before creating a problem. But mix the oil and the bull dust and coat the compressor, eventually shows up as a loss of power. So prior to that event, there was no routine compressor cleaning regime in place, but they soon established one. And most engines these days have internal cleaning procedures to maintain engine efficiency. The processes that are designed to remove the various contaminants from gas paths through the engine. Particularly engines operating in a marine environment suffer from salt build-up in the compressors and turbines. After the Air Force had fitted the big air filters, nobody thought about the need to routinely clean the engine and the compressor. We had tried to wash the compressor, but the dust and oil mix was too well attached and we made little impact. Probably would have been best to go out and do a bit of low-level operation without the filters and suck in a bit of that red dust and dirt, and it might have done the trick. I think it's one of the single otters, like a big one, Cessna 172, the tail dragger. Beginning of each winter, the pilots would come back from a mission flying up the range and complain about the cubby air temp indicator being wrong. And each time we'd pull out the indicator and take it into our instrument shop and check it out, and there'd be nothing wrong with it. And the bloke that ran the instrument shop, Lou, he'd been there for quite a long time. He was a Brit. We'd inherited at Short Brothers from the Air Force, and prior to the Australian Air Force he was with the RAF, and he kept really good records. And one day he showed me that this always happened on the first week of winter on either or both aircraft. always there was no fault found with the indicator. Now, the single otter is equipped with the Pratt & Whitney 1340 Wasp 9-cylinder air-cooled radial engine, about 600 horsepower. Has a carburetor and manual carburetor heat. And Lou's explanation was the pilots had been trained to place the carby heat selector in a certain position, and for most of the time it worked. It's just that at the start of winter it didn't. So apparently 4 notches up was the correct position most of the time. And with the beginning of winter, the standard lever selection was insufficient heat, and all of a sudden the pilot's peaceful jaunt up the range would be disturbed by rough running of the engine, and being startled back into full alert, they'd shift the carby heat lever and the problem would go away. But to cover their embarrassment, they always snagged the carby heat indication system, and we would dutifully remove the gauge and calibrate it, and then the next day when they reported again, we'd pull out the temp bulb and calibrate that, and it was all okay. And then we'd finally tell them that we'd re-rigged the system and that they'd have to experiment to find the best selection. So that's the cockpit of the single otter. Right, now sometimes you can't believe what the indicator is showing you. And not long after I'd arrived in Woomera, we had an interesting indication problem on one of the otters. The pilot reported that the cylinder head temperature indication system would rise normally, but reach a point when the needle started to move backwards down the scale to give a lower reading. And this was without touching any of the controls that normally would be expected to cause a change in temperature. So it's a pretty simple system. Thermocouple. It's a hot junction, cold junction over in the instrument, dissimilar metal. When you heat that up, indicator moves, tells you what temperature is. In the otter, it's that goes under the spark plug. It's on number 1 cylinder, which is the top of the round engine. And it works on the principle of dissimilar metals. It's iron constant, and the constant's a copper nickel alloy. And being heated causes electric current to flow. So I hadn't worked on the installation before, but I was in the troubleshooting and fixing. So after we'd taken the cowls off, I found the various bits of wiring had all been taped together to make things nice and neat. So that unwrapped that. I found that the CHT lead appeared to have been doubled back on itself and taped up. So I had to unwrap that as well. And there I found my problem. 2 wires, dissimilar metal, different colours. But the 2 longer leads had been connected together and doubled back. So instead of having just the hot junction there, we finished up with 2 more junctions out here. So as everything heated up under the cows, the poor little electrons didn't know which way to run. And so we had this funny indication to the pilots. So the fix really was that I had to take to the leg. No, different fittings to those, male, female screw fittings. And with a welding torch and some silver solder, we swapped over the connections so that we could connect it up with a red wire to red wire and a white wire to white wire, and wrapped it all up again with some insulation tape, and that fixed the problem. Now, I never did find out how the stuff up occurred. My best guess was it happened at a recent engine change, and back then I'd not developed my skills at ferreting the facts on who did what to whom and why, and that all came about later in my aviation career, and I'm still writing that stuff down. That's the engine in the Otter. Now, I'll just give you an anecdote that has nothing to do with gauges, but you might find it amusing. I liked the R2 engine and the Alouette. It was really interesting learning curve, and because of the engineering staff turnover at Woomera, there was no real consolidated bank of knowledge amongst the lamies. But I did learn that it was one engine that if it failed to light up during the start cycle, the problem could be rectified with a sharp calibrated tap from the handle of your screwdriver. Definitely. And it has that's the automatic start box. And when the pilot starts, he just throws a switch and goes through a cycle and some lights flash on and off. But if it doesn't, sort of what cuts out during the cycle, what we found was that it was a part of the gimmicky fuel system on this engine that had a barometric starting valve. And its sole purpose was to regulate the fuel to the engine depending on the ambient barometric pressure. And it always played up when there'd been a significant weather change. And so that's a typical aneroid capsule. And connected to the capsule in this barometric starting device was a long tapered needle, and that metered the fuel through an orifice. Problem was it tended to develop little notches on it, and as the weather changed, this needle would latch, and so you wouldn't get enough fuel for a start. But what normally happened would be the helicopter would be dragged back into the hangar and somebody would change the electronic start control card in that box. But with all the cluttering and banging around the engine, it would usually unlatch the barometric starting device, and of course the engine would start okay and they thought they'd fixed the problem. So I took over the electrical overhaul shop after some time in Woomera, and when I was surveying my domain I found about 10 of these start cards in a cupboard, all with unserviceable tags stating they'd been removed from the engine to rectify start problems. But I also found a test box with all the instructions in French. And I failed French in first year high school at Kent Street High School, and nobody could convince me at age 13 that it may come in handy one day. Now there were a lot of pictures in the glossy instruction manual, and I can read pictures because I'd read a lot of comics as a kid. And I figured out from the pictures that this box was for testing that box. I just had to disconnect all the aircraft leads and connect up my test box. It was a good bit of kit, and it must have cost the RAAF a lot of money. The pity they didn't get the instructions in English. But before I could connect it to the helicopter, I had to convince the Irish hangar foreman that I wouldn't burn the helicopter. And eventually I had my way, but with severe warning and finger waving, that be it on your head if any damage is done. Bloody Irish, he couldn't read French either. So after working out how it functioned, I then tested all those unserviceable control cards by mounting them one at a time in the box and playing with the test box. So we then put serviceable labels on them, put them back into store. And if only the blokes before me had known about the screwdriver trick, we could have saved a lot of time and effort. We did change a few barometric valves, but not that many.